The option enum is important because it allows us to either allow a value to be something or it could be nothing. The nothing aspect is comparable to null in other languages, whereas Rust does not have the null feature, it just uses none inside the option enum. So let's look to see how the option enum is set up. So we have enum option of a generic t, which we will learn about in the next section. And then inside this enum we have none, and then we have some t. And that's all there is to it, to the option enum. The t means it is generic, which, as I said, we will cover in the next section. But to simply put it, it can hold a piece of data of any type. You do not have to do anything in order to use this option enum, as it is already available inside the scope for us already. So I can delete all of this, and then in here we can say let some number equals sum 5, and just to make it clean it up. Let some string, and this is going to be a reference to a string slice, but a string. And then we can say let nothing equal of an option, and we'll specify that it's also an I8 equals none. So all of these are valid, and it is important to know that option t, so what we have here, this is the same thing as saying we're declaring the type, but behind the scenes, before we say it's an I8, it is option t, whereas let x equals 5 is equal to an I32. So I guess just to really clarify this, let's make that an I32. These two, when we declare option I32 and then we declare a variable to have 5, which is I32 by default, these are not the same. So we can show this by saying let x of I32 equal to 5, and then we'll say let y of option I32 also equal to 5. And it helps if I put the sum keyword. So now if we try to add these, let sum equals to x plus y, we see we get an error, and it says we cannot add option of I32 to I32. So you would have to convert the option of I32 to an I32 before we could perform this operation. So to wrap up what an option enum is, and when we want to use it, we would want some code that would run, but only when we have some t. And then that code uses the inner t, and remember, t is the data type. We would also want code to handle the case of when we have none. So we want code that can be able to handle something or nothing. Well, luckily for us, Rust gives us the match expression, which is a control flow construct that does exactly this when we use it with enums. So let's take a look at how that match statement works in the next lecture.